Welcome to this page of the notes, and the first thing we're going to do is meet that first objective or learning target, figuring out if it is a linear relation or function, right? Does it represent a straight line? If you were to graph it, would it be a straight line, a linear relation or function? Now, before I get into that, the first thing I want to point out is this. All linear equations can be written in this form, and actually you may see it like this, the ax, highlighter, ax plus by is equal to c. Most of the time though, you're actually going to see it written like this. Those will be capital letters A, B, and C. So it would be ax plus by is equal to c, capital C. That is the way that you will see it written most of the time. In fact, in later notes, I will write them with capital letters instead of the lowercase letters. So just be comfortable either way. And what this represents is the standard form for a linear equation. So anytime an equation is linear, you would be able to write it in this form, ax plus by equals c. Now let's go ahead and take a look at what it means to be a linear function. So I pull out my highlighter again, and here's our definition. These are the things you're looking for. The variables may not be multiplied together. You can't multiply variables. So when we look at our example problems, if you ever have variables multiplied together, it's not linear. They may not appear in the denominator, meaning the variables. So when we look at our example problems, if you ever have division by a variable, it is not linear. And finally, all the exponents must be 1. Please notice it is x to the first, y to the first. All right, you can't have any variables squared or cubed or to the 4th power. They all must be to the 1st power. And let's go ahead and take a look at the examples that I have given you. So here we go. I've given you a couple of examples of linear equations. A few things to point out. Please notice that it is in standard form. I have something times x, that would be ax. I have something times y, that would be by, and here's my c. In this one, y doesn't even have to be present. The reason is because I've multiplied it by 0. If my b is 0, 0 times anything is 0, that whole term drops out. I'm left with just the x. What is my a in this one right here? X is equal to 10. Your a would be, yes, that's right, a of course would be that implied 1 that is always in front of every variable, even if it's not written. So a would be 1, and then of course my c is 10. In this one right here, I have not written it in standard form. That's okay. This is a form you might recognize. We'll talk about it more later. This is the slope-intercept form, y equals mx plus b. The point is this. I'm not multiplying any variables, right? I don't have x times y. I don't have an x times an x. All of my exponents are 1. Nobody is squared or cubed or to the 4th power, right? And I certainly don't have division by a variable. Yes, I have a fraction here, but those are numbers, not variables, and that's perfectly okay. Same thing down here. I'm not multiplying any variables or anything like that. Now let's take a look at the ones that are not linear equations and see if we can figure out what part of the definition is being broken or what part of the definition is not met that makes these nonlinear. Well, we go ahead and take a look at the first one. It should jump right off the page at you. It looks like what has happened here is I have a y squared. Since all my exponents must be 1, I have the wrong exponent. My exponent is not 1. And anytime the exponents aren't 1, it's not going to be linear. In fact, we'll learn later on as we go through this course, anytime you actually have a variable squared, we have a quadratic function. They look like parabolas, right? U's that open up or U's that open down. Definitely not a straight line. We'll get to those in later chapters. The next one, you should recognize the square root. We talked about that before. Remember, the square root actually is a 1/2 power. It's a fractional power. So once again, for the exact same reason as the first one, I have the wrong exponent. I can't have a fractional exponent. It has to be the first power, and it's not. So this is not linear. I have the wrong exponent. And once again, later on in this course, we'll actually have an entire chapter on radicals. We'll see what their graphs look like. They actually are kind of like half arcs, and definitely not linear. Anytime the graph curves, it's not a straight line, and these definitely will have graphs that have a bend or a curve to them. We'll get to those in later chapters as well. The next one, what we see here, why is it not a linear function? Well, part of my definition says I can't multiply variables, and that's what I've got. So we have the multiplication of a variable. See if I can squeeze multiplication in here. Multiplication of a variable. All right, multiplication of a variable. Now the last one. We take a look at the last one, and hopefully right away we recognize what part of my definition was. I cannot divide by a variable. We can very clearly see that the x is in the denominator. I'm dividing by a variable. That is not allowed. So this would be nonlinear, and the reason is because I'm dividing by a variable. Division by a variable. I have division by x. So when I ask you on a quiz or a test, is the following function linear? Here's what you're looking for. Do you have any variables multiplied together? If you don't, then you're linear. Do you have anything raised to a power other than, well, anything? Do you have any variables raised to a power, right? I can have numbers raised to a power. That doesn't matter. I should have completed it, right? If I had this one, right? If I had 10 squared, I probably on a test or a quiz won't write it as 10 squared. I would actually write it as 100, so you don't have to really worry about that. But the point is what you're looking for. Do you have any variables raised to a power other than 1? If you do, it's not linear. And finally, check to see if you have division by a variable. If any of the variables are in the denominator, it is not linear. As long as you don't have any of those three things, right? You don't have multiplication of variables, you don't have division by a variable, and you don't have a variable raised to a power other than 1, it's going to be linear, all right? So check for those three things. If any of them are there, it's nonlinear. But if it passes all three of those tests, then you definitely have a linear function like these examples right here. Okay, let's keep going a little bit further down here on this page. What we've got is another way of representing linear functions. There is more than one way. The way I gave you above, the ax plus by is equal to c, is our standard form. But you should remember from Algebra 1 this form as well. This one right here, which is y, or well, f of x. Remember, they mean the exact same thing. F of x is y. Y equals mx plus b. Please remember that this is what we call the slope-intercept form. So this is the slope-intercept form. Slope-intercept form. And what's going to happen here is it's just another way of representing a linear function. So if you ever see anything written in this form, which we actually did right up here, both this one and this one are written in slope-intercept form. they still are a perfectly okay way of writing a linear function. So whether it's in standard form or slope-intercept form, that's perfectly okay. They're great ways of representing the equation of a line. What I've got for you then right down here is a couple of example problems, so let's go ahead and give them a shot. Try them on your own, see how they go, come back and check your answers. Let's see what we have. I want to know, is this a linear function? Well, we go ahead and take a look at it. Remember, first thing we're going to check for is, am I multiplying variables together? Well, as I look through it, I have an x by itself, a y by itself, and then an x by itself. None of the variables are multiplied together, so we're good. Then I check to see, are any of my variables raised to a power other than 1? Well, that's x to the first, y to the first, x to the first. We're good, so I've now passed 2 of the 3 tests. The third test is, do I have division by a variable? And aha, we do. We have an x in the denominator. That means that no, this is not a linear function. No. And the reason it is not linear is division by a variable. All right, let's try the next one. Well, in the next one, we're going to run through it, and we're looking for, do I have any variables multiplied together? Well, I have an x all by itself here. I have an x all by itself here. So, no, I don't. I don't have any variables that are multiplied together. All right, let's check and see, do I have division by any variables? Well, I run through there. None of those x's are in the denominator, so we're okay there. We've passed 2 of the 3 tests. The third test is, are all of the variables raised to the first power? And right away, aha, I see that I have a problem. My x is squared. Because I fail that third test, no, this is not a function. And the reason, I have the wrong exponent. Wrong exponent. That takes care of all the problems on this page of the notes. Head on over to the next page, and I'll meet you there.